Hi, my name is Mike Hells from Emerson. Today we'll be looking at the Smart Pneumatic Analyzer. This product is developed to give you an insight into the industrial Internet of Things and Industry 4.0. What we have on display here is an actuator commonly used in many industries, including the process industry and oil and gas. And this is a quarter turn actuator. It's a reasonable size, not too small, but again, actuators can be as large as this room. What we have on display here at the moment is that we're currently bringing the actuator up to spec. So I think this one's working about 4.5 bar. The actuator is open at the present moment in time, and what we have here is an overview of the actuator opening and the air consumption. And as you can see now that the air has filled up inside the actuator, we're levelling out. So we're getting to a medium stage at the moment where the airflow is constant and there's no leaks present. So in normal actuation, one of the issues that you do have is that you can have the possibility of the seal failing inside an actuator. In this, it's very difficult to see because there generally is very little noise coming out from the actuator, and you're not able to see that. But with our Smart Pneumatic Analyzer, what we're able to do is we're able to initiate that type of leak. So connected to this actuator, I have a very small flow regulator. And what I'll now do is I'll initiate a leak. As I say, this is just a 1/8 flow regulator, so the leak can be quite small. So that's showing the airflow through the leak at the moment, and that's around 20 litres per minute. So I'll reduce that leak down. As you can see on the graphical display there, we're showing it fluctuating as obviously the air has to build up, and the leak there is around 4 litres per minute. So again, you've got a graphical display to show you exactly what's happening. The compressor now is turned off, and again, it's quite a relatively small compressor. But what I'm going to do is I'm going to turn the compressor off completely, and I'm going to increase the leak again to maximum. I'm going to cycle the valve once. So now what we have is the holding pressure of the actuator. So what we're initiating here is a leak, and you want holding pressure within the actuator. So what you can see there is that the valve is still holding, but obviously there's a pressure drop in the line. So as we're depleting the air out of the reservoir, you can see that the changes are being visible on the actual display. But in a real world situation, you wouldn't be aware that there's actually a leak within your complete system. This leak could be a long way down the other side of your plant, and as far as you're concerned, your actuator is still in the actuator position. So again, as you can see, the smart pneumatic analyzer is seeing that there is a leak locally, and it's also seeing a pressure drop. So increase that leak to the maximum there. You can see now it's dropping quite rapidly, but the actuator is still staying in the actuated position. We're up to 30 litres per minute now on that leak. And as you can see, we're still maintaining the 4 bar, so that means the actuator is still open. So potentially this leak will be unknown. It's quite a big actuator, so I believe it drops out just under 2 bar. So again, for some period now we've had a large leak. The actuator is still in situ, it's still energised. And this could be over a long period of time. If you can imagine a very small leak and your compressor has a large volume, this could be over a long period of time, but maybe there's the compressors are turned off over a weekend, or there may be a fault, and you still want that line to stay open. As you can see now, we're getting to the point where the spring's overcoming the pressure that's inside the actuator, and the actuator is beginning to close. And that's the point of failure now. The valve is completely in the position. As the graph's changed now, you can see that the configuration is different to what we've seen before. And now I've nearly exhausted all the air out of the reservoir and the tank. And then from any point there we can go back in time and we can see the effect that that's had on our whole complete circuit. We can analyse this over a period of time, hours, months, days, and then across the bottom here this gives us some technical data that we've received from the compressor. So we've entered how much cubic metre per hour costs, what the energy consumption is. And these are really low figures. I mean, in reality, the figures are a lot higher than this, but it gives you an overview of what that leak is costing you over a period of time. But more importantly, it's indicating to you that there's an issue with your actuator. Maybe the seals are leaking over the top, there may be a leak on the line further down, and all of this adds to preventative maintenance. Thank you.